So I guess I'm going to use this. It's 4.6 volts, 900 milliamps, so it's almost an amp that this can put out, which is way more than what I need. Let's see. I don't have the right screwdriver to get these out, so I'm just kind of using a flat blade and just going to kind of wedge it in here. It's those damn tamper-proof Torx, and I have them, I just don't have them this small, so it seems to be working though. There will be different screws in here when I'm done. As a matter of fact, I'll probably just tape the damn thing together. So, this is actually nice though. This is a little mini switch mode power supply. That is I don't know how good you can see that. This is a really good option because I'm going to find a way to actually not need that voltage regulator. If I can figure out if I can find where the adjust resistor is on this, I can actually adjust this and I won't need the voltage regulator. Okay, so I think I got it figured out. This I see right here. I don't know what it is. It's marked 5295. Maybe somebody else will know what it is, but it's definitely some type of voltage regulator. There's no doubt about that. Now, when you're trying to figure out how to adjust the output voltage on a switch mode power supply, usually what you're going to look for is a voltage divider which has a voltage regulator, one of the pins from the voltage regulator tapping off the divided voltage. Okay, and one side of that divider is going to be to your ground and the other side is going to be to your positive rail on the output side. So I examined the circuit, and what I found is these two resistors right here. At first I thought this was my voltage divider, but this goes nowhere. Okay, so these two are just in series. But what I found is right here is ground. Okay, so this side is connected to ground, and this side right here comes up and it taps, or it connects right here to this pin on this unidentified voltage regulator. I think that's what it is anyways. And the other, if you follow that trace this way, it comes to this resistor right here. Okay, so our divided voltage is between here and here. Okay, and now if I follow this side of this resistor, it actually comes right here, which is my positive rail. This is my positive rail on the output. So these were 2.7K each, so 5,400 with the two in series. And this was 4.7K. It's not marked, but that's, at least in circuit, that's what it came up to. So what I'm going to do is, now the way you adjust is, if I want the voltage to go up, then I need to increase this value, and that way this regulator over here, or whatever it happens to be, it's going to get a lower voltage on this pin, and it's gonna do whatever it does, and it's going to make the SMPS increase the voltage. Okay, so it'll increase the duty cycle of the switch mode power supply, which will result in a higher voltage. So if I want to lower the voltage, then what I would do is I would reduce this resistor value, and that way, by reducing the value, that means the voltage on this track is going to be higher. It wants to maintain that 1.25 volts, so it has to either increase or decrease the duty cycle of the switch mode power supply to maintain that voltage. So that's actually how it's adjusted. So yeah, so what I'm going to do is I'm going to take this resistor out of circuit, and I'm going to try, I don't have any SMD components, but I'm going to try to find a resistor that's less than that. I might actually have a potentiometer that I could put in here, and then I can actually adjust it, and I can get it where I want it. Well, my output voltage that I need, my desired output voltage, is 3.3 volts. So if I figure out what I need to put here to equal that 3.3 volts, then I can, try to find, I'm pretty sure I can find whatever I need on another circuit board somewhere and snatch it off. So another way I could do it, and in fact I think I'm going to do that. What I'm going to do is I'm going to power this thing up, and I think I can do that. Yeah, if I power it up and I see what my voltage is at this point, then I don't know. No, I don't know if that would work. I was going to say if I knew what my voltage was here, maybe I could calculate it, but I don't know if that would be correct, actually. So, yeah, you know what? I'm just going to go ahead and do what I said and take that resistor out and put in a one of the smaller value, or if I have it, I'll put in a potentiometer. I think I have some, I don't know if they're the right value, but so I'm going to look for one of them, and then I will be back. Okay, so decided the first thing I'm going to do is I'm going to come over here to this side, and let's see, where are we? Okay, so what I'm going to do is I'm going to actually hardwire a plug to it, so I can actually plug it into a wall outlet, and field of view is so small. So anyway, though, you can see these metal things, which were how it was connected originally. So what I'm going to do is, well, I can tell because I have a fuse here and it's connected directly to this side. I know this is my line, and this other side over here is going to be my ground. Yeah, there's other ways that I could figure it out, but that's good enough. So what I'm going to do first is I'm going to desolder these little tab things. See how this is going to go. I'll probably burn my fingers doing this a few times, but yeah, we'll try to do it on camera. It's not the easiest thing. So here we go. So maybe I'm better off. I actually try to hold the circuit board So, and I'm going to do the same thing to this one. Just get it hot. There we go. So, okay, let's see. Get a little bit of solder cleared out. Okay, so yeah, I've got a okay, so let me switch to, so you can actually see what I'm doing. Probably helps, right? So I have just this ordinary cord and just cut the end off. And what I'm going to do is just wire this up on here. Really a trick to being able to strip wires with a pair of wire cutters, and it's not that hard. You just gotta have just the right amount of pressure so that you get the insulation but don't cut the wire. So, and of course it depends on the wires themselves too. Thinner ones are a little harder. Okay, so switching back to the microscope view. They're everywhere. So the first thing I'm going to do is I'm going to put a little bit of flux on my wire. So, flux and cat hairs actually. Okay, so find a little bit of solder. So the first thing I'm going to do is get here where you can see this. I'm just going to tin the wires. See, when they're tin like that, it just makes it a whole lot easier to get a good connection. I'm sorry you couldn't see that one. So, yeah, just like that. So, switch back to the main cam. Okay, so, as I said, the side here with the fuse is going to be hot. So, we're going to go with our black wire, which won't fit through the hole. Trick for that too. We're just going to take our needle nose and this flat part here at the back and squeeze, and I don't know if you can see that. Where are we? There you go. See on the microscope what I did there though. I just squeezed it flat. So, and in case anybody's wondering, I'm using one of those Andenstar USB microscopes for the close-up views like that, and it works. It's not the ideal thing to try to solder under because you got to be so close to it, but it works. I mean, it's within my budget right now, let's put it like that. When I can get something better, I'll do it. Definitely. But for right now, it works. Okay, so as you can see that sorta. So I got the wires through. I'm just gonna actually like fold them over and solder to these pads. So you can't see what I'm doing right now, but I will show you afterwards. Okay, so yeah, you probably can see it better on the microscope, and we got to go there anyway. So, and here we go. So as you can see, all I did is I just folded them over. So now what I'm going to do is just reflow that solder, and this second one here, I'm just going to straighten that a little bit, just to make it a little bit easier to solder. So, yeah, good enough. Okay, so good there. I'm just messing with the output wires real quick. Tied in a knot, and I'm going to replace them anyways, but for right now I just want to be able to connect to them. Let's see what my output voltage is. Okay, so back to, see, now I got a cord on it. Now it makes it a lot harder to position it where I want it. This is where a set of helping hands would come in handy, and I do actually have something that this would probably fit in, but I don't know where it is. Oh, there it goes. Okay. Let me see. Yeah, okay, scratch that idea. I was going to put it in a circuit board vise, but it won't fit because it's populated already. If it was upside down, it would fit, but then I wouldn't be able to do the work. So we're just going to take R30 out. Let's see, where are my tweezers? Okay, so what I'm going to do is I'm just going to, it's really small, so I'm just going to heat both sides of it. And it should actually just, I do have hot air, but I don't think that I need it for this. Yeah, the hell with it. I'm going to use the hot air. So, yeah, that's because it's got like this adhesive under it. It'll just make it a lot easier. Okay. That wasn't so bad. I hate it when they have that adhesive under them because this makes it a lot harder to get stuff off. They do that when they're wave soldering, so the components don't fall off. So just clean that up a little bit. Careful not to lift the pads off. So that will work. So the first thing I'm going to do is I'm actually going to try a 4.1K resistor that I have. So what I'm going to do is just do this in such a way that so I'm going to put a little bit of fresh solder on the pads, a little bit of flux. Probably don't really need the flux because the solder has it in it, but makes life easier sometimes. So a little bit of solder. There we go. Okay, and the resistor will be coming next. So as I said, it's 4.1K, and I don't have a surface mount one, but it's just a test, so the idea is that if I'm correct, then my output voltage should be lower. And don't worry about these don't worry about these legs touching anything, because I'm actually going to make sure that they're not when it's done. So right now I just want to get it in place. Not the easiest thing to try to do on camera, I'll tell you that. Yeah, okay. Flux. So I'm going to try to do it different. So I dropped the resistor. I'm looking for it. Here it is. Okay, that's lucky. I'll tell you what, if that was a surface mount one, I would not be finding it. Not that fast anyways. Sometimes maybe, but... So I'm going to try holding it with the needle nose. Maybe it'll work a little better. Try to get these pins cut to the same length and maybe get a little bit of fresh solder on my iron. And we're going to win this time. Okay. Yeah, so that time we won. So what we're going to do now is we're going to cut this ridiculously long wire. I don't know if you can see that, but that's actually how it was. Well, they had it stripped like that and wrapped around the red wire going through the casing, so instead of actually having the two wires both sleeved and then an outer wire around. It's really weird how they did it. Don't know why. Seems it would have been safer this way. So I'm going to grab my other... Okay, so... So I'm just gonna, instead of switching meter probes, I'm just gonna put these little alligator clips and put them on, let me see, connect them up to the meter, and I'm gonna give you a meter view. Let's see, switch back to the DSLR. And we have a frozen image. Let's see. And okay, here we go. So I think that's going to be backwards, so put it this way because I want you to be able to see it. What can I do to get to that there? There we go. A little blurry, but okay, so close the window. Live view. Focus. Okay. Okay, so I'm going to plug it in and hopefully not blow up. So if I blow up, you'll be the first to know. Actually, you probably won't know because the video would never actually make it onto YouTube. So, well, there you go. our output voltage is backwards. There you go. Okay, so our output voltage is 2.5, and that's not enough. We want more than that, but it tells us that I successfully identified how to adjust this. So at this point, what I need to do is add some more resistance in this. So if that was 4.1K, let me see if I can actually find that little resistor. It's here somewhere. I took it out and I didn't intend to lose it, but I think that I lost it. Oh, no, there it goes. Switch to microscope. No, you know what? Excuse me. I'm going to let you see the meter. There you go. And what I'm going to do is take these probes and I'm going to try and see what our resistance is. See, out of circuit, this thing might have a different resistance than in circuit. So I said it was 4.7K. Oh yeah, wow, look at that. It's actually 16K. Okay, so what you're looking at right there is a 10K resistor. I knew that I could find one, so I'm going to pull that off of this scrap board and try to do it on camera. I don't know why, but I guess because if I don't, you can't see it. So okay. So that is a 10K resistor. Let me get this board out the way. I want to not lose this. I actually try to do this with hot air. Not the easiest thing to do. If my air is too high, it's going to blow away. It's on there. Alright. A little bit of fresh flux, and I'm just gonna put a dab of solder. Find it. The problem is I got wires on it, and every time I move I hit the wire and pulls it out of view, so there we go. It's not very straight, but because it's on there, and it ain't touching nothing it shouldn't be touching. It's good enough for me. Switch back to the DSLR. No, okay. And I'm going to plug this in. Let me turn that off. Probe leads. Well, we gotta switch this to DC, and we got 3.59 volts. So 10K is a little bit high, but I think this will be fine. So there we go. That is how you take a switch mode power supply and change the voltage.